Hi, my name is Feliks Pobiedziński. I am a software developer at Software Mention and member of a membrane team. Today, I will show you how you can stream, decode, and detect in Elixir with Boombox. And maybe some of you are wondering right now, what is Boombox? Or maybe you have heard something about it, but not enough to answer this question. And before I'll do it, I will start from the beginning. And in the beginning was Membrane. Membrane is an Elixir framework for building custom multimedia processing pipelines. We've been developing this framework for the last few years. Here you can see the chart illustrating contributions to Membrane Core repository. And Membrane Core is the base of the framework, and it's only a part of the whole Membrane ecosystem. In fact, Membrane Framework GitHub organization contains over 70 plugins, and each of these plugins supports specific multimedia codec, protocol, format, or container. And you can use these plugins to build up custom multimedia processing pipelines that can be suited to various set of use cases. The flexibility that is offered by Membrane causes that it can be used in very wide range of problems. And if you have a multimedia problem that you want to solve, there is a very big chance you will be able to do it with Membrane. However, everything comes with a price. While we've been developing the framework, we always kept in mind to make it as simple as possible, and in the same moment, to support possible wide range of usage scenarios. And then, after a time, we concluded that sometimes it might be difficult to provide customizability of your framework without losing its simplicity. And there are situations where you have to go on some trade-offs to some degree between making your framework flexible and keeping it simple. And therefore, this conclusion led us to create Boombox. Boombox is a very high-level Elixir library for streaming and processing audio and video. It provides really simple API. To run Boombox, you have to type boombox run in Elixir and specify its input and output. Boombox will spawn under the hood an appropriate membrane pipeline that will take multimedia streams from the specified input and will forward them to the desired output, so that you don't have to think on your own what type of membrane pipeline you need to implement. You can also use Boombox to ingest multimedia streams into the Elixir code, or you can feed Boombox with audio or video generated in Elixir as well. In case if you want to do something more custom and you still want to use Membrane, now you can plug Boombox into Membrane processing pipeline so that it will simplify its shape and remove the part of the complexity from your code. And last but not least, yesterday we have released Boombox in Python. So now you can spawn Boombox from Python and exchange multimedia streams between Python code and Boombox. And this makes integrating Boombox with AI models in Python easier than ever. And if any of you have ever worked with multimedia, you would probably know that it's a part of computer science that is unbelievably messy and chaotic. And working there means having to deal with ultra-long documentation, standards overriding standards, weird fixtures that breaks these standards, but you have to support them one way or another, or even memory leaks in signaling messages. Therefore, implementing things from scratch in multimedia seems to me like a very crazy approach. And if I would have to point one thing from my today's talk that you will remember, it would be this. Using Membrane to solve multimedia problems is a good idea. Membrane is a powerful tool, and it allows you to do difficult things in an easy way. However, it still requires some level of at least superficial knowledge about the framework and about the multimedia in general, while Boombox is designed to be so easy that it could be used by almost anybody who can code. and it's still quite powerful, and I will try to prove it to you in my demo. And I decided in my demo to take a live stream from some street camera from the internet, use Boombox to decode the stream and to ingest it into my code. Then I will pass the stream through AI model that will run object detection on it to at the end use another Boombox to visualize the stream with drawn model output. And to use it, in my demo, I will use YOLO. YOLO stands for You Only Look Once, and it's a class of object learning algorithm that take the picture and say what types of objects are in the picture and where exactly these objects are placed. So to give you an example, YOLO model took the original image as the input and returned the coordinates of bounding boxes as well as labels indicating what type of object is inside each box. And to use YOLO in Elixir, I will use YOLO Elixir library from HexPM. You can also take a look at its source code at GitHub, and I guess that there will be a talk at this conference tomorrow about YOLO Elixir. Okay, so let's think right now how our demo could look like. First, we could start with using Boombox to take the stream, decode it, and ingest into our code. Decoded video stream is a stream that is represented as a series of images, like a snapshot of the video stream. And frames of decoded stream are called raw frames, as you can see. Then you would pass the stream frame by frame to YOLO model. Then we would visualize the model output as bounding boxes to, at the end, use another Boombox to play the modified stream. And this approach is not bad. However, there is one problem. The model I decided to use proceeds a single image on my computer for around 250 milliseconds. It means it can handle 4 frames per second, while the stream we want to modify has 30 frames per second. And it wouldn't be a problem in offline processing, but we want to keep it live, so we have to figure something out. And we can do a simple observation that usually in video streams, following video frames are very similar to each other. Therefore, maybe there is no need to pass all frames through the model, but only part of them, and it will be enough. And keeping this idea in our minds, I will propose a solution to this problem. I will spawn a special gen server. I will call it YOLO gen server, and it will receive all frames returned by Boombox. When the first frame will hit YOLO gen server, it will spawn a separate helper process in order to run YOLO model prediction concurrently. While the prediction will be in progress, following video frames will hit YOLO gen server, and it will store them in a special queue in its state. Then, when the prediction is completed, it means we already know the coordinates of bounding boxes containing objects from the first frame. For the first frame, YOLO gen server will draw bounding boxes on all stored frames. It means we'll propagate the prediction results from the first frame on several following as well. Then, after drawing bounding boxes, YOLO gen server will send a batch of modified frames to Boombox that will play the stream. And after flushing its queue, when the next frame will hit YOLO gen server, the whole cycle will be repeated. So, to sum it up, in my demo, I will spawn YOLO gen server that will work as I described. Then I will start Boombox that will take the external stream and will send raw frames directly to YOLO gen server, and YOLO gen server will send modified streams to Boombox playing the stream. So now let's see the code of our demo. First, I will start with defining depths. Of course, I have to add Boombox to my depths, as well as YOLO Elixir and Exla in order to speed up any extensor operations. Then I will add 2 lines to config file of my project. I will define config for Ortex and Nx. And both libraries are used under the hood by YOLO Elixir. Ortex is a library that is responsible for executing AI models serialized in ONNX format, while Nx is something like an Elixir equivalent of Python NumPy. And now we are ready to start writing our Gen server. In the starting function, I will set parent process option. And parent process is a process that will receive modified video frames. Then in init callback, I will load YOLO model, and to do it, I have to specify a type of model implementation I will use, paths to the serialized model and to a file with classes data, and I will tell YOLO to use hardware acceleration. Then I will initialize the state of my Gen server. I will store the parent process from init option, freshly loaded model, as well as queue to store packets and a flag indicating if the prediction is running in the background or not. Then in process frame function, I will cast Boombox packet to my YOLO Gen server. And in this case, Boombox packet is the same as raw frame and the same as image, almost. In appropriate handle cast, I will receive the raw frame. And now let's handle the case where the current packet is the first packet in the cycle. So it means we want to run model prediction on this frame that have just arrived. So to do it, I will call YOLO detect function and YOLO to detected objects that will take the model output and convert it into more human readable format. Because, as I said earlier, I want to perform model prediction in a helper process, I will wrap this piece of code with task start link. And when the prediction is completed, helper process will notify the Gen server about its results. Then, no matter if the current packet is first in the cycle or not, we'll store it in the queue in our state, and we'll set the detection in progress flag to true, because now we can always be sure that the detection is running in the background. And last thing we have to do is to handle detection completed message from our helper process. As I said earlier, I will take all packets stored in the queue, and I will draw bounding boxes on each packet using one helper function from Kino YOLO. And then I will send updated packet to my parent process, and I will set detection in progress flag to false, and I will clear packets queue. And now our Gen server is ready. So we can go to the implementation of main demo function. I will start with spawning YOLO Gen server. Then I will initialize HLS URL variable. HLS is a multimedia protocol that is broadly used for broadcasting live video stream over the internet. And I can show you from where I had took the stream. I have found one, I will use the live stream from some street camera from Salerno in Italy. And it's going live, and I can show you the trick how to get HLS playlist address from this kind of websites. To do it, you have to inspect the website, go to the network tab, and add M3U8 filter here. Because M3U8 is the extension of HLS playlist. And last thing I have to do is just to copy the address of the playlist. And this trick doesn't work always, but usually it does. So once we know the address of HLS playlist, we can go further. And okay, so I will start the first Boombox. I will set its input to HLS address, and I will set its output to stream tuple, because I want to get from this Boombox an Elixir stream containing raw video frames. And I will iterate over the stream and send each frame to YOLO Gen server. And because enum each will last till the stream flows through Boombox, I will wrap this piece of code with task start link. Then I can receive modified packets from YOLO server, and I will do it inside stream repeatedly function, so that it will produce an Elixir stream containing modified video frames. Last thing I have to do is to pass this stream to Boombox Play and set some parameters to let Boombox know that it should expect only video with no audio. And now we are ready to run our demo. So I will go to the to code of the demo. I will ensure that HLS playlist address didn't change. It's valid, okay. And now I will run it. And let's see how it works. So it's the same stream that I showed you earlier. Yeah, with bounding boxes generated by YOLO Elixir in real time. And the whole processing takes place, as I said, in real time. And yeah, this is the demo I wanted to show you today. Yeah. And mainly, I wanted to show you how easy it is to do something with multimedia with Boombox, because implementing multimedia part of my demo from scratch would mean having to scratch regularly HLS playlist, figure out what segments of the stream you need to download, demax the stream, remembering that HLS playlist can have different types of containers, decoding the stream, and doing this everything in real time, while now the whole work is packed inside Boombox, and you don't even have to know that it's going what's happening under the hood. And yeah, it's the end of my presentation.
This is super cool. Any questions?
Could you please explain when you get the stream and then you see the difference between the image before you send it to the model? Because as you said,
I can barely hear you, sorry.
all right. Yep, thanks for the talk. Very interesting. My question is if you could explain more about when you check the difference between your stream to send to the model. Because as you said, you have 30 frames per second, and then the model only takes 4 per second.
Yeah, the main idea was to, because we wouldn't be able, because the stream flows in real time through my code, so I want to run model prediction in real time as well. And I'm not able to run model prediction on all frames because I would be a few times slower than real time. So the main idea was to in fact, I'm running the model prediction on every 8th frame or something like this. And this this trick with the queue, it allows me to not fix the value, the n, that every n frame is passed through the model, let's say. So I don't have to fix the n, but dynamically adjust to the velocity of frames and to the time that model spent on the single prediction.
So you don't crop the image?
Yeah.
You just take every...
Yeah, I don't crop the images, but I am skipping, I'm propagating the prediction from some of the frames on their neighbors. And you was able to see that people on the stream, they are moving fluently. There is no, you don't see the specific frames, but you see the specific frames of model prediction. You know, the rectangles are clicking, but it is because I run the model, I don't know, 3 times per second, 4 times per second, because drawing bounding boxes also takes some time.
Another question?
Where can we find the source code for your
Where can we find this?
You know, like I haven't published it, like it's on GitHub, but I haven't published it yet. But you know, like I will. My name is Feliks Pobiedziński, and I will put the link to the demo today, maybe on my LinkedIn, or maybe I don't know if I can do it with the conference app.
Yeah, there might be a way.
So I will share it today. I will try to share it today on my LinkedIn. Maybe like this is the best idea I have. Yeah, like I have in my mind right now. Sorry, but this is the QR code to Boombox docs.
One more question.
Regarding Boombox, it's a stream processing framework, as I understand. Is
Yeah.
it also capable of doing non-multimedia stuff, or is it specifically designed for multimedia?
It's for multimedia. It's like the membrane is a framework. So like membrane is a framework, and when you work with membrane, you are obligated to write your membrane modules in the specified format, because like in any other framework. And Boombox is a library, so it's not like the Boombox uses your code, but you use Boombox as in the demo. And the membrane is packed inside. And membrane and Boombox, like you can, for example, write a membrane element to run AI on the stream, but in general, membrane was designed to. It's a multimedia processing framework, and Boombox is also a multimedia tool.
I was just wondering if we could reuse it for other purposes, like JSON streaming, but that's not the case.
If you want to stream something, then probably you can use membrane, but like there will be always multimedia somewhere.
All right. Thank you again, Felix.